Hey, we're taking derivatives, and this particular one here is an exponential function, and this is the rule that we're going to follow to take the derivative of this. So a is considered to be our 2, and our h of x is 3x up here. So we're going to take the derivative of the exponent and bring it out front. So the derivative of 3x is 3, and then we end up just rewrite the whole thing. All right. And then times the natural log of the base, and our base here happens to be 2. That's our a, so that would be the natural log of 2, and we're finished. Alright, so let's refresh our memory here on that rule. Alright, so we take the derivative of the exponent, so the derivative of x is 1, and then we just rewrite times the natural log of the base, and the base happens to be 5. And of course, to finish this problem out, to simplify, I guess I don't do that here, but right, we wouldn't have our final problem as 1 times 5x. It would just be 5x times the natural log of 5. Alright, a little bit longer problem here. We've got f of x is equal to x squared plus 1 in parentheses times 6 all raised to the x cubed plus 2x plus 1. So we're going to do the product rule. So I'm going to take the derivative of x squared plus 1 first. So the derivative of x squared is 2x, and of course the derivative of 1 is 0. So we just have 2x times, and then we just rewrite the second function here, plus, then rewrite the first function times the derivative of this guy right here, the second function. So remember, we take the derivative of the exponent. So derivative of x cubed is 3x squared, plus derivative of 2x is just 2, and of course the derivative of 1 is 0. Make sure we put this in parentheses now. Times, and then remember, you just rewrite, and then times, and then it's the natural log of whatever the space is, and this should be a 6 out here. Okay, so the natural log is 6. Alright, now we've got to do the algebra and clean this thing up. So let's see, what do I do here? Looks like I factored. Looks like I did some factoring or something. Boy, it's been a while since I did this problem, but what did I do? Okay, I think I pulled the 6x cubed plus 2x. Okay, I pulled this guy out. Since it's occurring over here and it's occurring over here, right, so I just pulled it outside and then started a parentheses, and if I pull this out, and I see here, yeah, okay, never mind. Alright, so I pulled this out, and so we're left with a 2x and then an x squared plus 1. Sounds kind of complicated. Okay, so I pulled this out, we're left with a 2x and then plus, and then because these guys are all multiplied by each other, right, just pull that completely out, and we're left with x squared plus 1, 3x squared plus 2 times natural log of 6. These parentheses are really important here. Okay, and then let's see, what did I do from there? Oh, I think I just multiplied these guys together here. X squared times 3x squared is 3x to the 4th. Let's see, 2x squared plus 3x squared is 5x squared. 1 times 2 is 2, and just left the natural log of 6 alone. And I think that's about as far I'm going to go on that. Alright, in this one here we've got y is equal to 10 raised to the x minus 2. So we're going to use that rule. We're going to take the x minus 2, we're going to take the derivative of the exponent, bring it out front, so the derivative of x minus 2 is just 1, times, rewrite, times, then the natural log of the base, and then it'd be the natural log of 10. Alright, so we want to write our final answer. We definitely don't want to have this 1 times, so ones kind of like just disappear when they're coefficients. So we're left with the final answer 10x to the negative 2 times the natural log of 10. That will be our derivative.